Alright, welcome to the Inequalities unit review for Algebra 1 Honors. Number 1, solve and graph. So we're going to add 6 to both sides. So negative 3x is greater than negative 12. Divide both sides by negative 3. And x is going to be less than 4. Remember, it's less than because we're dividing by a negative. So there's my solution. To graph it, I'm going to place 0 and positive 4 on my number line. Since it's strictly less than, it's an open circle, and I'm going to point left for less than. Number 2, given the number line, select the appropriate inequality that satisfies the number line. Show work to justify. So what I'm going to do is I know I have this equation or inequality over here, and I'm going to go ahead and solve it without a sign and see what I get. So first thing I'm going to do is divide both sides by negative 5 to get rid of that multiplication. So x minus 2 is something and negative 3. I'm going to add the 2. So x is being compared to negative 1, which we have here. Now my final answer, that is since it's pointing less, that's a less than sign. So I have to have my final answer is less than or equal because it's solid. But somewhere up above, in fact in this first step we divided by negative, so it means that it had to flip at some point, which means it had to start as a greater than or equal to sign. So that's going to be greater than or equal. Number 3, Orpheum Theater seats 1,364 people. There are already 576 seated. Write an inequality to represent the situation. So if there's 576 people plus x number of more people has to be less than or equal to 1,364 total people can show up. We're going to remember that because we go to part B. How many people can still be seated? We've got 576 plus x is less than or equal to 64. So we're just going to subtract 576 from both sides. And when we do that, I get that we can still seat less than or equal to 788 people. Number 4, Danielle is purchasing candy from the dulceria. Each candy costs 50 cents. If she purchases at least $10, she gets a coupon that can be used on her next purchase. Write an inequality to model the situation. So inequality is it costs 50 cents times the number of candy she buys, and she wants to buy at least, it says greater than or equal to $10. There's my inequality. 5. Jorge got a job as a student tutor. He makes $20 per day but spends $2 on gas. He's going to go to a math camp and needs to save $150. So part 8, write an inequality representing the number of days that he needs to work to earn at least $150. So he makes $20 per day, but then he spends $2 per day, and that needs to give him a total of at least, that's greater than or equal to $150. So if we combine these, we get 18x is greater than or equal to $150. There's his equation. Part B, determine how many times he must attend, or how many times he must work to reach his savings goal. We're going to solve that for x. So 18x is greater than or equal to 150. Divide by 18. So x is greater than or equal to 150 divided by 18 is 8.3 repeating. But we can't work a third of a day. So if he works 8 days, that's not going to be enough because it has to be greater than 8.3. So we're going to go ahead and round that up to x has to be greater than or equal to 9 days. Part C. If Jorge tutors 25 times, but spends some of his earnings on a new skateboard that costs $100, determine if he saved enough money to cover his camp expenses. So we know he makes a total of $18 per day, but he's going to spend $100 at some point. We want to know if that's still greater than or equal to 150. So we're going to solve that for x. So 18x is greater than or equal to 250 divided by 18. X is greater than or equal to 250 divided by 18, which gives us 13.8 days. So if he works at least 13.8 or at least 14 days, he's going to make enough money. Since he's working 25 days, yes, he's going to have enough. Will have enough. Alternately, what you could have done, you could actually plugged in a 25 for x. So we could have, instead of solving for x, we could have said 18 times 25 minus 100. We wonder if that's greater than or equal to 150. So 18 times 25 is 450 minus 100 gives me 350. And since 350 is greater than 150, he will have enough money. Number 6 and 7 require you to graph the solution. So to graph a linear inequality, we're going to find m and b. Remember, to find m and b, we need to be in slope-intercept form. M is -1, b is +2. Because it's a less than or equal to sign, it's going to be a solid line, and we're going to have to check a point. And we can check 0, 0. So I'm going to go ahead and do that now. 0 is less than or equal to -0 plus 2. 0 is less than or equal to 2. That's true. So we're going to be able to shade 0, 0. So if we plot our points, we get 2, and then we have our slope. Go ahead and make our straight edge with our line. There's my line. And then we're going to shade. And we already decided that 0, 0 was a true statement. So we shade the side that 0, 0 is on. So 0, 0 is right here. So everything on that side of my line gets shaded in. So there's my solution. 7, very similar problem, except y is not by itself yet. I have to divide everything by -1 first. So we're going to get y is greater than or equal to 4x minus 2. Remember, we have to switch the sign because we divided by a negative. And we have m is 4, b is -2. It's again going to be solid. And if we check a point, we can again check 0, 0 because it doesn't go through there. So I'm going to check it in the original. So it's -0 is less than or equal to -4 times 0 plus 2. So 0 is less than or equal to 2. That's again true. So if we graph our line, we start at -2, up 4 over 1. I'm not going to have enough room to go up 4 and over 1 again. That's okay though. It's again a solid line. I'm going to have, oops, grab the wrong one there. So there's my line. And again, we're going to shade the true side. Since once again 0, 0 was true, we're going to shade the 0, 0 side, which is here. So we're going to shade everything, in this case, above the line. And there's my solution. Alright, moving on. Number 8. Magali is selling t-shirts and hoodies. She will sell t-shirts for $10.50, hoodies for $20. In order for her new store to stay in business, she must sell at least 200 per hour. Let X represent the number of shirts, Y is the number of hoodies. Write an inequality representing the situation. Okay, so if X is shirts, we know that she sells a shirt for $10.50. So that's $10.50 X, that's the amount she makes from all the shirts, plus Y is the number of hoodies. She makes $20 per hoodie, so 20Y is the amount she makes from all the hoodies, and it needs to be at least, so greater than or equal to 200. There's our inequality. Part B asks us to graph that inequality. So I'm going to just rewrite that. A couple ways we can do this. We could solve this equation to get y by itself. But since we're already in standard form, it's going to be a lot simpler to find the x-intercept and the y-intercept and just plot those points. So that's what I'm going to do. Remember, x-intercept, y has to be 0, and the y-intercept, x has to be 0. So if I plug in 0 for y for my x-intercept, I'm just going to have 10.5x. It's greater than or equal to 200. Divided by 10.5. X is going to have to be greater than or equal to, that ends up being 9 point something. It ends up being 9.04, or I'm sorry, 19.04. We're selling shirts though. X is the number of shirts. We can't sell 19.04 shirts, so we're just going to say that's about 19 shirts. And we do the same thing for y. We're going to plug in 0 for x, so it's 20y is greater than or equal to 200 divided by 20. So y has to be greater than or equal to 10 hoodies. So all I need to do is plot those 2 points. I know that my x-axis is t-shirts, because I was, and my y-axis is hoodies. So if I go ahead and plot those 2 points, I know that I have 19 t-shirts, which puts me right there, and I've got 10 hoodies, which puts me here. So again, if I draw my line, it's going to be a solid line because it's got to be greater than or equal. And I don't even need to worry about like checking a value this time. I could if I wanted to, but if we just think logically about it, we need to sell greater than that amount. So if we sell anything down here in this little triangle in between the x, y axis, this little triangle between 10 and 20, that's not going to be enough. This line that we drew is exactly $200. So we want to sell something greater than that. We want to sell more than that amount. So we're going to shade above that line. We're going to shade greater than that. All right, number 9. These are the piecewise functions. So for number 9, your routinely charges according to the total weight. If your yogurt weighs between 0 and half a pound, the rate is 150. If your yogurt weighs between half a pound but no more than 1 pound, it's 250. If it's over a pound, they charge you $3.50 for the first, plus an additional $1 for every pound after the first. So we've got some things to fill in. Let's start with our first function is what happens when we're between 0 and half a pound. And we know that we get charged a flat rate of just $1.50 for anything in there. The next interval is we get charged $2.50 if we're anywhere from greater than half a pound all the way up until 1 pound. And if we're greater than 1 pound, we get charged $3.50 for the first plus an extra $1 for each pound after that. So we know that first of all, our interval x is greater than 1 pound. I'm not ready to put it in a function here yet. Let's think about what is going on here. So we get charged $3.50 for the first pound plus an additional $1 for every pound after that first pound. So if x is the number of pounds, we want to take away that first pound. Remember we did some problems like this earlier in the year with like the data on a cell phone plan. So we have $3.50 for the first pound, $1 for every pound after that. X is the number of pounds, but we have to take away that first pound because that first pound was already included in the $3.50. So if we simplify this a little bit, we get $3.50 plus x minus 1, we can combine some like terms, and we get a final answer of $2.50 plus x. And if you want to check that, let's think about what happens if we get 2 pounds of frozen yogurt. That's a lot of frozen yogurt, but you never know. So we get charged $3.50 for the first pound, plus an extra $1 for every pound after that. So that would be an additional $1 because we got charged $3.50 for 1 pound plus an extra $1. That's $4.50 total. If we plug that into our function, we'd get $2.50 plus 2 for 2 extra pounds. $2.50 plus 2 is still $4.50. So our equation works. Part C, apparently. I guess we're not going alphabetical. We're going to do C before B. What would Yogurtini charge if your item weighs 5 pounds? So if it's 5 pounds, we're obviously in this last section. So it's $2.50 plus X, which means it's $2.50 plus 5, because it's 5 pounds. So that's a total of $7.50. And then finally, we're going to graph this. So if we're between 0 and half a pound, we're getting charged $1.50. So from 0 pounds to half a pound, that's this first interval here, we're getting charged 50 cents. So we have a horizontal line, we have an open circle at 0, closed circle at half a pound. Our next interval is $2.50, and if that's we have $2.50 if we are in between half a pound and 1 pound. And let me fix that. I didn't read my own graph correctly, so let me go back and fix that. It was $1.50, so I should be up here at this line. Closed circle, open circle. That's a little bit better. All right, and now $2.50 for the next half a pound. So open circle, closed circle. So it's $2.50 for the next half a pound, from half a pound to 1. Then after that, we need to graph this function, $2.50 plus x. So from that function, we know that our graph starts at y-intercept at $2.50, and we go up 1 over 1, but it doesn't start until 1. So what we're going to do, we're going to start our graph at, I'm going to use another color just so we can see what's going on. We're going to start our graph at $2.50, up a pound, over a pound, up, over, and we get this line connecting those green dots. Now, we don't start counting that green line until 1 pound, which is at this point here, which should be an open circle. So we don't care about that y-intercept, it just helps us graph the line. And now we can draw the correct line, and there's my graph, showing that we started with $1.50 for the first half a pound, $2.50 for the next half a pound, and then here's my function for anything greater than that. Last problem, graph the function y equals -5 when x is greater than 2, and +5 when x is less than or equal to 2. Alright, so the boundary line that we have is at 2. So just for a minute, I'm going to draw a vertical line through +2. That's my boundary line. And now I'm going to look at what happens on either side of that. So for the top function, it says we use -5 when x is greater than 2. So when we're bigger than this boundary line, we have a horizontal line through -5. So it's going to look like that. And when x is less than or equal to 2, we have a horizontal line going through +5, but that's going to go this way because we're less than or equal to 2. Draw a nice horizontal line. There we go. Now I can delete my boundary line. And all we need are open and closed circles. So the -5 should be an open circle, and the +5 should be a closed circle. So the +5 is a closed circle, the -5 is an open circle, and that is going to do it for the inequalities review. Good luck on the test.